Okay, today we're going to talk about something called the fundamental theorem of algebra and how we can write equations from zeros, which are zeros are solutions. We're actually going to take this lesson 6.7 in two pieces. So today we're just going to talk about our fundamental theorem of algebra and how to find solutions. And then tomorrow we'll talk about kind of the backwards process of that, and if we have the solutions, how we could work our way back to what the original equation is. So the word fundamental in and of itself really kind of means like two things. What does fundamental mean? Basic. And so like if I'm thinking about like a sport, so we're in basketball season, so some fundamentalist basketball would be like dribbling, passing, layups, free throws. These are basic ideas to the sport, but also like super important, because if you can't do these, then you can't really build from there. Right. So the fundamental theorem of algebra is basic to the idea of algebra, but super important. Like all of algebra is built upon this idea, just like the rest of basketball is built upon basic basketball skills. So the fundamental theorem of algebra says that if we have a function, which we could just call f of x, and it's a polynomial, which means all powers of x's, so like x to the fourths, x to the thirds, that kind of thing. Then the equation where we take that polynomial and set it equal to 0 has at least one solution. So basically this tells us every equation is solvable. Okay? Then furthermore, breaking that idea down, it says including repeated zeros, and we'll talk about what that is in a minute. A polynomial has the same number of solutions as its degree. Its degree is its highest power. So if it's an x to the fourth equation, it should have 4 solutions. If it's an x to the 7th equation, it should have 7 solutions. Whatever its highest power is, it should have that many solutions. Not all of them are necessarily real, but it has that many solutions. It says if a function bounces off the x-axis, we call that a repeated zero. So what that would look like graphically is if my function did something where it just kind of hits and then turns around and then comes back. So right here, this would be a repeated zero because it just bounces on the axis. Usually it's a double. So usually that would count as kind of 2 answers. And then any crossing would be another answer. So this one probably has 3 answers to it. And then our last one says that imaginary answers happens in pairs. And that is because when we solved our quadratic formula, we always had a plus or minus, right? And that plus or minus really gives 2 solutions then. Imaginaries always have to happen in pairs so that they can cancel each other out, okay? So those are the big basic ideas of algebra. Every equation is solvable. Whatever the highest power is, we should have that many solutions. Some of them might be real, some of them might be imaginary, but we should have that many solutions. Imaginaries are going to happen in pairs, and if it bounces, we get to count that as more than one answer. So now we're going to learn how to find some of these solutions. We are going to use our calculators, or if you have an app on your phone or something like that, to find some of our solutions. But that will only allow us to find our real solutions. And then we'll need to find our imaginary solutions after that. So what we're going to do, it says find all the zeros of, and then it gives us this big equation. First step is going to be to graph and find all the answers that we can find off of our calculator. We have skipped some sections of the book. So the last section of the book that we did was section 4, and now we're doing section 7. Some of the stuff that we skipped talked about how to find all of the solutions by hand. It's a little bit ridiculous to me. I appreciate the idea of knowing what your calculator is doing. I don't like just teaching students like, here, just plug this in your calculator and it pops out an answer and you have no idea where the answer came from, but there it is. I don't like that because I want you to be smarter than your technology. You need to know how to use it appropriately. But at the same point in time, there comes some problems that it just gets a little bit too tedious and ridiculous. And finding those answers by hand is just something we're not going to worry about. So we're going to start by finding any of our real answers off of our calculator. So what I'm going to do is on my calculator,
in my y equals, I'm going to clear any equation that might be in there, and I'm going to type in this polynomial. So x to the power of 5 and so on and so forth. You don't have to type in the f of x because that's like the y equals, but you just type in all the stuff that's on the other side. Okay, and once I get it all typed in general, you'll just be able to hit the button that says graph. For this very first time we do it, I'm going to have us hit zoom and choose choice 6 that says zoom standard. That'll make sure that we're all kind of looking at the same window of our graph. But from now on, you can just type it in and then hit graph, and you'll see your function. Okay, so it looks like some disconnected pieces here, but this should really be a connected function. So that means what happens is it starts out down low, it shoots up in the air, and somewhere off the screen it turns around and comes back down and makes that little dip and then goes back on up. Okay. What we're looking for are places that this graph touches or crosses the x-axis, and those are going to be our solutions. So when I look at this graph, I see a spot over here and a spot over here. You're only going to have nice answers. I think in your homework there might be one that has a decimal, but it's 0.5. Okay, so for today, you're only going to have solutions that are nice solutions. So they're going to be integer solutions with no decimal, or if it looks like it's crossing kind of right between two of the little hash marks, then you're just going to say it's a 0.5. Okay, so here, that first one on the left, what is that solution? Or does it look like it's crossing? You can't really see the hashes once I drew my circle in there, but that looks like it's happening at -2. 2 hash marks over. And then this other one, where does that look like it's hitting? At +1. And it's bouncing, so that's going to count as a double solution.
We're saying where it's hitting on the x-axis?
On the x-axis, yeah. We're looking for x-axis solutions. So we've got a solution at -2 that crosses over. We've got a solution at +1, and that bounces, so we get to count that really as kind of 2 answers. So from our graph, we see 3 answers to this. What is the highest power in this equation? 5. So according to our fundamental theorem of algebra then, if our equation is x to the 5th, we should have 5 solutions. So we have 3 solutions that we can see. We can't see the other 2. That means they're imaginary. So then step 2 says we're going to use synthetic division, which we learned like a week ago, with the solutions that we found to get our function down to a quadratic that we'll be able to solve for those imaginary solutions. Okay, so our solution so far are -2 and then a solution of 1 counted twice. I'm going to need some room to do this, so I'm going to go to a whiteboard. So far, we have solutions of -2 and 1 and 1, because we get to count that one twice. And our function was x to the 5th minus 2x to the 4th, 8x squared minus 13x plus 6. Okay, so synthetic, which we learned about a week ago. We learned that we're going to start with our highest power in the equation, which may or may not be the first thing, but we find the highest powered thing. Then count our way down to the 4th, to the 3rd, to the 2nd, to the 1st, and constant. We must represent every power of x counting down, even if it's not represented in the equation. Then we write our coefficients underneath these. 1, -2. There are no x cubes. 8 x squareds, -13x's, and 6 for our constant. Then we're going to plug in one of the solutions. It doesn't actually matter what solution you plug in first. Leave a blank line. And our process of synthetic was to carry down the first value
Anything that's under the line, we multiply by what's in the box, and then add them up. Multiply by what's in the box, add it up, multiply, add it up, multiply, add, multiply, add. You must get 0 as your final number. If you don't, you've done something wrong. Because what we're plugging in is a solution, and we learned the other day that when you plug in a solution or a factor, that should have a remainder of 0, or that last value should be 0.
Is that the -2 on the side, is that from multiplying the x equals -2 times 1 times 1?
Nope, that -2 on the side is from our first solution. We have to plug them each in individually, so we don't multiply them together. We're just going to plug in one at a time.
So then we'll plug in 1 and then 1.
Yep, so now we're going to plug in 1, but instead of going back to the original equation, we're just going to plug in 1 from here. So from this last set of numbers, we're going to plug in 1. So we're going to keep on building in the problem instead of going back to the beginning each time. So again, we carry down 1, multiply, add, multiply, add, etc. on through. And again, you should get 0 this time as your second to the last answer because we're working our way in. We're trying to reduce down this equation. So each time you do it, you should get 1 more 0 at the end of the problem. Now 1 was a double solution, so we're going to plug it in again. And this will be the last thing that we plug in with synthetic. I'm going to carry down. Multiply, add, multiply, add, multiply, add. And again, you should get 1 more 0 in. Alright, now if the original equation started as x to the 5th, we learned that when we do the synthetic division process, it reduces the power by 1 each time. So after doing it once, we would have been down to an x to the 4th. After doing it again, we would have been down to an x to the 3rd. And so now we are down to an x to the 2nd. So now we have a quadratic equation that we need to solve. X squared minus 2x plus 3 equals 0. We need to solve. These will not be factorable because the answers we're expecting are not going to be real answers. Because if they were real answers, we would have seen them. So since we can't see them, we know these answers are going to have to be imaginary. So we're going to use our quadratic formula to solve this. A is 1, B is -2, C is 3. It's just those numbers from the very end, so you don't even really have to put in your x squared and x. You'll just notice your A, B, and C are the 3 numbers that are left there at the end of all of that division. And then, hopefully you remember from chapter 5 your quadratic formula. If you don't, look up the really annoying song on YouTube again. And then we plug it in. So, -2, so minus square root, -2 squared minus 4 times 1 times 3 over 2 times 1. It's 2 plus or minus. I can do all that stuff underneath the square root at once. You can plug it into your calculator if you want. Just be careful with parentheses. But I get 4 minus 12, which is -8 under there. You should always expect to get a negative under your square root because we're expecting imaginary answers. So now we need to simplify this down. How do I simplify the square root of 8? 4 and 2, which makes it then 2 square roots of 2, and it was negative, so I over 2. And then we learned we can divide that 2 into both parts. So I get 1 plus or minus square root of 2, I. That's 2 solutions because it has the plus and it has the minus. Okay, so that's 2 solutions. On the calculator we found -2, 1, and 1. So now that is 5 solutions. And that's how many we expect because it was an x to the 5th equation.
Why would you do 1 plus or minus 1 square root -2i?
You could put a 1 in front of the square root of 2, that's fine, but 1 times square root of 2 is just square root of 2. So it's fine to put the 1 or not, either way. Okay. These problems are a process. There's no denying it. But all I can say is, at least I didn't make you find -2, 1, and 1 by hand. Right? Because that's what we skipped in a section. So we would have been learning how to find those by hand in the previous section. So at least we're not doing that. Okay? But there's no way to make the calculator pop out the imaginary answers for us because the calculator can only give us what we can see. So that is something that we have to do by hand to find the imaginary solutions. Okay? Let's do another example.
Is just these 5 problems due tonight or the next?
Yeah, there's just 5 problems due tonight. Yep, because we're taking the lesson over 2 days. So to start the problem, we start on the calculator. In the y equals, we want to graph the given equation. So go x to the 3rd plus x squared minus x plus 15.
What's the windows on this?
My window is -10 to 10, or I just hit zoom standard.
Yeah, because mine's super zoomed in.
Okay, yeah, I just do zoom standard. And that gives me where I can see -10 to 10, and that will give you enough room to see all the solutions to the problems that we'll have today. Alright, so when I graph, I'm looking for places that my line either crosses or touches the x-axis. And what do we see?
-3.
Okay, it looks like I have one solution right here, and that looks like it's happening at -3. Remember, it's going to be all nice integer numbers unless it looks like it's happening right between 2 hash marks, and then we're going to say it's a 0.5 for today, okay? Later on, we will learn how to find ugly solutions, but for now we're going to be working with nice solutions. So we've got one solution of -3. Our equation has what degree or highest power? 3. That means I should have 3 solutions to my equation. We only see one. That means the other 2 must be imaginary. So we're going to do synthetic to find them. X to the 3rd, x squared, x and constant. Coefficients, 1, 1, -1, and 15. And we plug in the solution that we found on the calculator, which was -3. Process is carry down, multiply, add. If this started as an x cubed equation, after we plug in one value, we should be down to an x squared, which is where we can then solve by hand with the quadratic formula. A is 1, B is -2, and C is 5. Just those numbers that we get after our last division. So we plug those into the quadratic formula. X equals -b plus or minus square root b squared minus 4ac divided by 2a. Everything under the root you can plug into your calculator, just be careful with parentheses. I get 4 minus 20, which is -16. You should always expect to get a negative underneath that square root because we're expecting imaginary answers, and that's where imaginaries come from, is a negative square root. So if you get a positive under the square root, you know you've done something wrong because that would be a real number and we would have seen that on the graph then. What is the square root of -16? 4i. And then we can divide that 2 into both parts. You get 1 plus and minus 2i. That's 2 solutions, because plus and minus. And then the calculator gave us a solution of -3.
So that's 3 solutions, which is what we should expect for an x to the 3rd equation. Questions?
Could you just keep it on this page? Right?
Yep. Let me know when it's good to go. All right, good to go? All right, so we begin on the calculator by typing in the equation and looking for as many solutions as we can find. How many would we expect for this equation? 4, because it's x to the 4th, so we're going to expect 4. We'll hope to see 4, but if we don't, then we'll have to do our work to find the rest. All right, so this is what my graph looks like. So then I want to look for any place that this graph touches or crosses the x-axis. So reading across from left to right, what does it look like that first solution is? -3. And what's special about that? It bounces, so it's a double. So that actually counts as 2 answers. There are 2 answers of -3 to this. And then what's the next one? -1. And what's the next one? 3. So we found 4 answers then, since that bounce gets to count double. So we've got answers of -3, -3, -1, and 3. And x to the 4th equation should have 4 answers. So we're done with that one. There's no imaginary, so there's no work to do. The calculator does all the work for us.
What does that line mean, like the separate line?
It's actually connected. It's not a separate line. It's just that this graph is going to go way down here somewhere and then turn around and then go back up. Yeah. So it's all one line. It's just that we can't see it all.
Why does it bounce along too?
Because in a factored equation, if we were going to factor this whole thing, and you don't have methods to factor something like this, but if we were going to factor it, it would have a factor of x plus 3 and another factor of x plus 3,
Okay.
and then plus 1 and x minus 3. And we'll talk more about that in tomorrow's lesson. Yeah.
Where did I get this to zoom out?
Zoom standard. Harrison?
Can you explain how there's like you don't have to find another answer again?
We expect to find as many answers as the highest power. So since there's a highest power of 4, we expect to find 4 answers. We found 4 answers on our graph since that bounce gets to count twice. And so we found all the answers that there are. So doing a synthetic won't give us anything new other than what we already have.
What about like the last one we did, the last part of the x to the 3rd, and then we had 2 answers.
Oh, we had a plus and minus,
Oh,
which is 2 answers, and then we had the one that we got from the calculator. Yeah.
Mine doesn't show me this way.
I know.
Mine show me that way.
Can I borrow a calculator, please?
When you go to do that. Well, if you do it once.
You were in the right window.
Or standard.
Oh, I got
Nuts.
It looks like you might have typed that in wrong.
it. I have a different calculator.
Yeah, yours is
Oh, I don't know how to do it.
I am just going to have 2.
All right, we have one more example to look at, and then if you're having calculator issues, I can come around and help you kind of fix those individually.
Did you rear back
Yeah, not on the down row. I'm going on that too.
All right, so for our last example,
We start on the calculator. How many answers should we expect to this equation? 3 because it's next to the third. So we type in our equation as it is.
It's mine.
Yeah, I hovered and then realized I was wrong. Okay, so once I get it typed in, we said we were expecting 3 answers because it's next to the third equation. How many answers do we see? 1. Where is it? X equals 1 is the one answer that the graph gives us. So then we need to do synthetic to find the other ones. They must be imaginary, and that's why we can't see them, because we can't see imaginary things. For synthetic, we start at our highest power and count down. Write our coefficients. We're going to plug in the one solution that we found, which is 1. Process is carry down, multiply, add, multiply, add, multiply, add. You must end up with a 0 as your last value. That's what lets us know that this is really truly a solution. Since we started at next to the third, this equation should be an x squared equation. Plus 0x doesn't really matter, so I can say that this equation is x squared plus 25 equals 0 and just ignore the x term. I could do a quadratic formula on this problem, and a would be 1, b would be 0, and c would be 25. And that's totally fine to do it that way if you would like to do it that way, but I think it is easier to solve this problem with square roots. Because that x term disappeared, we had 0 x's, square roots are a legal way to solve this. If the a, b, and c are all there, then you have to solve with the quadratic formula. But if that b term is 0, there's an easier way to solve this. I can subtract 25 from both sides and take a square root of both sides, and I get x equals what? Plus or minus, every time you take a square root, 5i. So that's 2 solutions because it's positive 5i and negative 5i. And graphically, we found a solution of 1. So that's 3 solutions to this equation. Okay? Your homework is just the first set of 5 problems there from 6.7. Tomorrow we'll talk about the rest of 6.7 and then you'll do the other 5. Okay?